Hello everyone. Okay, so in this video we're looking at rational inequalities. So this is just a step above quadratic inequalities. We're going to end up with quadratic inequalities by the end of it. But what are rational inequalities? Well, rational inequalities are simply inequality equations with fractions. So 3x minus 2 all over 2x plus 1 is less than or equal to 3. That's it. Bada boom, bada bing. That's all it is. So the only caveat, the little caveat with rational inequalities, ladies and gentlemen, is when if we had a normal rational equation, say if that wasn't less than or equal to 3, say if that was just equal to 3 here, I would multiply across by 2x plus 1 to get rid of the fraction, because we don't like fractions. We want to get rid of fractions whenever we can. But I'm not dealing with equal signs, is it? No, I'm not dealing with equal signs. I'm dealing with inequality signs. So I can't just multiply across by 2x plus 1, because this is where I'm George Explorer and you have to answer me back. Why can't we multiply across by the denominator? Muy bien. It's because I can't say for certain if my denominator is positive or negative. So, for all I know, right, the value of x could make my denominator negative. So, in that case, right, if I multiplied across by the denominator, I would have to swap the sign. But I don't know. I don't know until I solve it what the case is going to be. So, we multiply across by the denominator squared. So we multiply by both sides by the denominator squared. And we do that because anything squared is positive. So anything squared is positive. So therefore, if my denominator was negative, we're squaring it and we're multiplying across by a positive number. So I don't have to worry about flipping signs or nothing or nada. Right? So easy peasy, lemon squeezy. So steps in solving a rational inequality was, so I said, multiply both sides by the denominator squared, and then we solve the resulting inequality. So here's an example here. X plus 1 all over x minus 1 is less than 4. So I need to multiply both sides by x minus 1 squared. So that's going to be x plus 1 all over x minus 1 multiplied by x minus 1 squared is less than 4 times x minus 1 squared. So I'm going to have here x plus 1 all over x minus 1 times x minus 1 squared. Well, one of these x minus 1s is going to divide into one of these. So the squared will cancel here. So I have x plus 1 times x minus 1 is less than 4 times x minus 1 all to be squared, which is x squared minus 2x plus 1. So multiply this out. I could go to the effort of multiplying this out. I know I could do that. But my little mathematical brain, this is the H1 difference, ladies and girls. Ladies and girls, boys and gentlemen. No, not boys. Anyway, get the point. That's the H1 difference I'm noticing here. Well, that is a factorized form of difference of two squares. That's the aftermath of me factorizing my difference of two squares. So that's A, that's B. I could say that's going to be x squared minus b squared, which is 1. 1 squared is 1. Anyway, do you have to know that? No. But it's just the H1 difference, saves me from that saved me them precious valuable seconds multiplying that out. Right. So I multiply my bracket here. It's 4 times x squared is 4x squared. 4 times minus 2x is minus 8x. And then 4 times 1 is 4. So I have a quadratic here. I want to bring everything over to one side. So I'm going to bring everything over to the left or to the right. So 4x squared minus x squared minus 8x plus 4. Then this minus 1, bring it over. It's going to be 8 plus 1. So I'm going to have here 3x squared minus 8x plus 5. So I have 3x squared minus 8x plus 5 is greater than 0. So see here, 0 is less than 3x squared minus 8x plus 5. That's the same as 3x squared minus 8x plus 5. So now we need to solve this inequality, which we've done before. This here, hello, well, that just means above the x-axis. I'm looking for the values greater than 0. So I'm looking for the values above the x-axis. I need to solve this. So 3x squared minus 8x plus 5 equals 0. 3x x equals 0. I'm going to have here minus 5 and minus 1. So I'm going to have 3x minus 5 equals 0. X equals 1. 3x is going to equal to 5 over 3. And x is equal to 1. So, just x is equal to 5 over 3. So I've solved my roots. Plotted out. Boom, boom. So I have 5 over 3. That is bigger than 1. So that's my rightmost root here. 5 over 3. And then 1 is my smallest one. So that's my leftmost one. I'm looking for the values above the x-axis, remember? So I'm looking for these ones. So if I want to go over here, x has to be less than 1. And if I want to go over here, x has to be greater than 5 over 3. Bada boom, bada bing. Right, let's look at some of past exam papers. So this is from 2018. Solve the inequality 2x minus 3 all over x plus 2 is greater than or equal to 3, where x is an element of real numbers and x is not equal to 2, right? So what's this mean? X is not equal to minus 2, so I should say. Why did he put that there? Why is that relevant? It's formality, really, because it is the domain of my function, right? So this function will exist for any value of x, but x equals minus 2, because if I sub in x is minus 2 here, it's just a bit of a tangent, but deal with it. 2 times minus 2 minus 3 all over minus 2 plus 2, I'm going to be left with minus 7 over 0. And you can't have anything divided by 0, so you're going to get an error on your calculator. So when you draw this graph, it would like ding, 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 boop, disappear at x equals minus 2, and then it'd be like ding, 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 ding. Anyway, you'll learn more about that at functions and limits, but you know, bring it in now. Right, so 2x minus 3 all over x plus 2 is greater than or equal to 3. I need to multiply both sides by my denominator squared. So I'm multiplying both sides by x plus 2 squared. Greater than or equal to 3 times x plus 2 squared. So one of these x minus 2 is going to divide into that one. So I'm going to have 2x minus 3 times x plus 2 is greater than or equal to 3 times x plus 2 squared, which is x squared plus 4x plus 4. I'm going to have here 2x squared plus 4x minus 3x minus 6 is greater than or equal to 3x squared plus 12x plus 12. 2x squared plus x minus 6 is greater than or equal to 3x squared plus 12x plus 12. Bring everything over to one side. So 3x squared minus 2x squared is just x squared. 12x minus x is going to be 11x. And then 12 plus 6 is going to be 18 plus 18. Now I have my quadratic here, so I have x squared plus 11x plus 18 is less than or equal to 0, right? So I just rewrote that. So less than or equal to 0, I'm looking for the values below my x-axis. So I have here, let me solve this now from my roots. I'm going to have x plus 2, x minus 9. So x equals minus 2, x equals 9. There are my roots. Plot them out. Minus 2, 9. I'm looking for the values below the x-axis. here according to this little inequality here. So I'm looking for these ones here. Bing, 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 bing. Minus, oh, sorry, that's a plus 9. That's plus 9 here, so my answer is minus 9. Minus 9 is my leftmost value. Minus 2 is going to be my rightmost value. So my inequality is going to be, well, x is going to be greater than or equal to minus 9, but less than or equal to minus 2. And that's my answers there. All right. Let's look at the 2012 ones. This is from 2012, paper 1, question 1, part B. Find the set of all real values for x for which 2x minus 5 all over x minus 3 is less than or equal to 5 over 2. So, I hate fractions. I hate fractions. We don't like fractions. I want to get rid of my fractions. So, I need to multiply both sides by, well, first of all, I'm going to multiply both sides by 2 because I want to get rid of this one. Notice how I don't need to square the 2 because it's positive. So I can multiply across my inequalities by a positive number, right? Then here, I need to multiply across by x minus 3. But remember, we don't know if that is positive or negative. So I have to say x minus 3 squared. So 2x minus 5 all over x minus 3 times 2 times x minus 3 squared is less than or equal to 5 over 2 times 2 times x minus 3 squared. So one of these x minus 3 is going to divide into one of these ones. This 2 is going to divide into that 2. So I have here 2 times 2x minus 5 times x minus 3 is less than or equal to 5 times x minus 3 squared. That's going to be x squared minus 6x plus 9. I'm going to have here 2 times 2x times x is 2x squared. 2 times minus 3 is minus 6x minus 5x plus 15 is less than or equal to 5x squared minus 30x plus 45. 4x squared, that's going to be minus 11x. Multiplied by 2, that's going to be minus 22x plus 30 is less than or equal to 5x squared minus 30x plus 45. Bring everything over to one side. 5x squared minus 4x squared is x squared. Minus 30x plus 22x is going to give me minus 8x. And then 45 minus 30 is minus plus 15. So that is going to be greater than 0. So x squared minus 8x plus 15 is greater than or equal to 0. Because remember the big mouth is pointing towards my quadratic, so it's bigger. So bing, bong, bing. I'm going to have x minus 3, x minus 5. X is going to equal 3. X is going to equal to 5. So plot out my... sketch out my quadratic here. So 3 is going to be my leftmost one here. 5 is going to be my rightmost one here. I'm looking for the values greater than 0. So I'm looking for these values. So I'm going to have here x is less than minus 3 and x is greater than 5. And it's actually greater than or equal to, so less than or equal to minus 3, greater than or equal to 5. Right? Yeah, 2 more questions left. 2x minus 1 all over x plus 1 is less than or equal to 0. This is from 1992, when the world was in sepia tone. So, 1992, paper 2, question 1. Second paper question 1. 2x minus 1 all over x, paper 2. Solve 2x minus 1 all over x plus 1 is less than or equal to 1, where x is an element of OR and x cannot equal minus 1. So again, that is just formality. They're just telling you by the x can never equal minus 1. You're rarely ever going to need it, but it's just something they kind of have to put there just in case so no one complains. So this is an easy one. I just need to multiply both sides by x plus 1 squared. So 2x minus 1 all over x plus 1. Multiply both sides by x plus 1 squared. So the one of these x minus 1s will divide in here. I'm going to have 2x minus 1 times x plus 1 is less than or equal to x plus 1 squared. 2x times x is 2x squared. 2x times 1 is 2x. Minus 1 times x is minus x. Minus 1 times 1 is minus 1 is less than or equal to x squared plus 2x plus 1. So I have 2x squared plus x minus 1 is less than or equal to x squared plus 2x plus 1. Bring everything over to one side. So I'm going to bring it all over to the left now. So 2x squared minus x is x squared. X minus 2x is going to be minus x. Minus 1 is minus 2 is less than or equal to 0. So less than or equal to 0. I'm looking for the values below the x-axis. Solve this. X minus 2 plus 1. So x is going to equal to 2. X is going to equal to minus 1. Sketch it out. Boom. There's my graph. Rough sketch. Ding. Ding. So my leftmost one is going to be minus 1. My rightmost one is going to be 2. I'm looking for values less than 0. So they're below the x-axis. So these ones here. So, and then my inequality sign has the equal bit in it. So I have x is going to be greater than or equal to minus 1, but less than or equal to 2. And that's my answer there. And then finally the last one, this is from the 1900s, the late 1900s, 1990. The Leaving Cert High Level Paper 1, question 1. Find the range of values for x for which x plus 2 over x minus 1 is greater than 1, for x is an element of real numbers and x is not equal to 3. Right? Again, formality. It's a formality because we have x minus 3 here, and if x did equal 3, my function does not exist. So x plus 2 all over x minus 3 is greater than 1. Multiply both sides by x minus 3 squared. So x plus 2 all over x minus 3 times x minus 3 squared is greater than 1 times x minus 3 squared. X minus 3 divides into 1 here. So x plus 2 times x minus 3 is greater than 1 times x squared minus 6x plus 9. Multiply this out. I'm going to get x squared minus x minus 6 is greater than x squared minus 6x plus 9. Ooh, very interesting, very interesting. So this one actually doesn't work out to be a quadratic. It's actually going to be a linear inequality. So bring everything over to one side. It doesn't really matter what side I bring things over. I'm going to bring everything over to the left. So x squared minus x squared is going to be 0. Minus x plus 6x is going to be plus 5x. And then minus 6 minus 9 is minus 15 is greater than equal to 0. So now I actually have a regular linear inequality. I don't have a quadratic one. Bada boom, bada bing. Easy peasy, lemon squeezy. So I just need to bring everything over to the right. So 5x is greater than 15. I can divide both sides by 5. I'm going to have x is greater than 3. So when x is greater than 3, my function is going to be greater than 1. How fun is that? So there you go, that's my answer. X is greater than 3. What a nice one to end on to revise linear inequalities. Right, so again, same thing, right? Can't really get more complicated than that, really. I hope this video was some help to you. And I'll catch you guys later. Bye-bye.